Here we're going to look at rational exponents, so continuing to talk about radicals and exponents and how that correlates to writing as a radical or writing just as an exponent. Rational exponents, if we have a to the 1 over n, that would translate to the nth root of a. Nth root of a. So that denominator indicates the index of the radical. So it'd be the nth root of a. So for example, let's go through these problems. Number 1, 16 raised to the 1/2. So it's 16 being raised to the 1/2. So this 2 indicates the index, so this would be the square root of 16. What is the square root of 16? The square root of 16 is 4. That's one thing you want to make sure you're doing. It says here right in the directions, simplify if possible. You don't want to just leave it as conversion of 16 1/2 is square root of 16. You want to actually evaluate and simplify everything down. So number 2, the cube, spoiler alert, 27 to the 1/3 is the cube root of 27 because the 3 is the denominator that determines our index. The cube root of 27 is 3. 3 times 3 times 3. Let's get you back to 27. Number 3, x to the 1/4. So that means we're going to have the 4th root of x. And we can't do anything with that. Just the 4th root of x is the 4th root of x. Can't evaluate that. Just leave it as the 4th root of x. Number 4, 0 raised to the 1/5. That is going to be the 5th root of 0. And that's just going to be 0 because 0 times 0 is 0. 0 times 1,000 zeros is still just going to be 0. So that's just going to be 0. Number 5, -4 to the 1/2. And number 6, parentheses, 81x to the 12 to the 1/4. And maybe you already know why I did 5 and 6 and talked about the setup. Both of those. This is -4 to the 1/2, meaning negative times the square root of 4. That negative is not being raised to the 1/2. If it was like this, where it's parentheses being raised to the 1/2, then you'd have that negative underneath the radical. But it's not. It's -1 times 4 to the 1/2. So that means it's -1 times the square root of 4, which is -2, because the square root of 4 is 2. And then 6, that's parentheses, all being raised to the 1/4. So all of this is going to fall underneath that radical of 81x to the 12th. So now we have to do the 4th root of 81, the 4th root of x to the 12th. So the 4th root of 81 is, I believe, 3. Let me just double check real fast. I don't want to say anything. Yeah, it's 3. So 3, and then x to the 12th being raised to the 4th power. That would be x to the 3rd. Remember, x to what power? Being raised to the 4th power. That'd be x to the 3rd. And number 7. 9x to the 1/3, same discussion that I had here about number 5, only the x is being raised to the 1/3. So this is 9 times the cube root of x. Those problems are really making sure you're paying attention to, is it underneath the parentheses? Is it all being raised to that same exponent? What's happening there? So that's really what the key is there. Okay, next form, a to the m over n. So now we have that same thing where we have n as the denominator, so that indicates our index. But now we have this numerator of m, that is the exponent. So this could be a to the m underneath the radical of the nth root, or it could be the nth root of a being raised to the m. So you could either do it as a on the inside being raised to an exponent underneath that radical, or that radical being raised to the exponent. I would probably, most of the time, I think this form would be a little bit more helpful because we're going to be raising numbers to exponents. In some cases, I'm not saying like this is the go-to method. I'm just saying in some cases, I think this might be a little bit more helpful because in this case, like it might get a little bit difficult at times, but well, it just kind of depends on each scenario. So let's take a look. So number 8, we have n to the 3/2. So that translates to the square root of n, because the denominator is 2. Did I say n? I meant 9. The square root of 2, the square root of 9, being raised to the 3rd power. So I'm taking this denominator That becomes my index. Square root of 9, and then 3 is that exponent. So the square root of 9 is all being raised to the third power. Square root of 9 is 3. And then we have 3 to the third power, which is 27. So we do have like a sequence that we have to follow through on. We have to take the square root, we have to raise that to the third power, and it depends on the problem. We might have to take like a cube root or a fourth root or raise it to some exponent, but we do have a sequence that we have to simplify out. So then simplified would be 27. Number 9, I have negative 81 3/4. So the negative is not underneath that exponent of 3/4. So the negative is going to be on the outside. We have the fourth root of 81 being all raised to the third. And the negative is not being raised to the third. Again, only the 81 is. Only the 81. So we have to do the fourth root of 81, raise that to a third, then multiply by that negative. So the fourth root of 81 is 3. I already talked about that on number 6. Fourth root of 81 is 3. And you'll notice the more you do, the more you see the same type of numbers. So the fourth root of 81 is 3. So it's going to be negative 3 to the third. 3 to the third is 27, so that's going to be negative 27. Number 10, everything is being raised to the 2/3, so that negative 8 is all being raised to the 2/3, so that's going to be the cube root of negative 8 squared. So the cube root, because the denominator is 3, so the cube root of negative 8. Cube root of negative 8 is negative 2. Negative 2 times negative 2, negative 2. So negative 2 being raised to the second power. Negative 2 squared is positive 4. Pretty cool how that one happens. Negative 2 times negative 2 is positive 4. Number 11, 1/4 being raised to the 3/2. So that is going to be the square root of 1/4, all being raised to the third. This is interesting. That looks like it's just going to break down and really nothing much is going to happen. But remember what we said before about taking the square root of a, or not just the square root, but the radical of a fraction. You take the square root of the top, square root of the bottom. So this is going to be the square root of 1 over the square root of 4, still all being raised to the third. Square root of 1 is 1. Square root of 4 is 2, still all being raised to the third. And look what happens. Everything's being raised to a third, so this is 1 to the third, which is 1, 2 to a third, which is 8, so we get 1/8 there. So that's a really cool sequence, because we have the square root, because the denominator is 2, so that indicates we're taking square root. We have a fraction, so take the square root of the top, square root of the bottom, and then a lot of simplifications can be made. So that one is actually 1/8. And finally, number 12 on this set of examples, we have this expression 3x minus 1 being raised to the 3/5. So just practice writing this out. This is going to be the fifth root of 3x minus 1. And this is all being raised to the third power. You could also rewrite this as the fifth root. I know I'm getting kind of close to my camera. The fifth root of 3x minus 1 being raised to a third like that. These are also equivalent statements. I think this example is here just to help show you that you could put that 3 on the inside, so that whole entire expression of 3x minus 1 is being raised to the third. But at the end of the day, it's all underneath the fifth root, but just practice kind of going both directions there with that one. Let's move on. So same discussion, but now we just have negative exponents. So a to the negative m over n. So let's just now have a negative exponent. How do we apply negative exponents? If I had x to the negative 2, that would be 1 over x squared. That would just have to come down. If I had 1 over x to the negative 2 like that, then x to the negative 2 would come up, so then that'd be x squared. So just negative exponents, those are rules that you should hopefully know before watching this, before getting to this point. So the same rules apply for m over n. The n indicates our index, the radical, and then m is the exponent, but we just have to maneuver some things. So on 13, write each expression with a positive exponent, then simplify. 64 raised to the negative 2/3. That's going to be 1 over 64 raised to the 2/3, because this has to just come down. So just negative exponent rule. And then we just do the same thing that we've been working on. This is the cube root. This is being raised to the second. So 1 over the cube root of 64 being raised to the second power. 1 over the cube root of 64 is 4. It's 4 times 4 times 4. And then we have that being raised to the second power. So this is 4 being raised to the second power. 4 squared is 4 times 4, which is 16. So 1 over 16 after we simplify that one down. Cool problem. Number 14. In parentheses, negative 32 being raised to the negative 2/5. So just practice bringing that down. So 1 over. And then this is still negative 32, though. That doesn't go away. The only thing that we're addressing right now is that negative exponent, where that has to come down. So let me rewrite that. So that's negative 32 being raised to the positive 2/5 now. We apply our exponent rule. So 1 over. And then we're going to have the 5th root of negative 32 all being squared. 5th root of negative 32 is negative 2, because it's an odd exponent, 5, or not an exponent, but an odd index, so 5. So negative 2 to the 5th would get us back to negative 32. So 1 over, and that would be negative 2 being raised to the second power now, because the 5th root of negative 32 is negative 2, and then that's all being raised to the second power. So negative 2 times negative 2 is positive 4, so 1 over 4. Cool. A lot of good rules. Now we're applying old skills of what do we do when we're multiplying by the same base? What do we do when we're dividing by the same base? These negative exponent rules. So now we're just pulling out a lot of previous knowledge that you should hopefully have at this point. But this is really what these skills are doing. And now we're just applying those radical properties. So it says use properties of exponents to simplify. So we have x to the 1/3 times x to the 8 over 3. We're multiplying by the same base. So what do we do when we're multiplying by the same base? We add exponents. So this is x to the 1/3 plus 8 over 3. So 1/3 plus 8 over 3. When we're adding, same denominator, 8 plus 1 is 9. 9 over 3. 9 divided by 3 is 3. So we just get x to the 3rd. Cool. Number 16. X to the 1/2 times x to the 2/3. So whenever we're multiplying by the same base, we add the exponent. So 1/2 plus 2/3. Least common denominator would be 6. So times 3 times 3 times 2 times 2. So x to the 3 over 6 plus 4 over 6. I'm going to go kind of fast through just adding fractions together, because this is previous knowledge. So x to the 3 plus 4 is 7. 7 over 6. Number 17, 5 to the 1/3 over 5 to the 4/3. So when we're dividing by the same base, we subtract the exponents. So this is going to be 1/3 minus 4/3. You could also do big exponent minus a small exponent. You know what? I'm going to go that route. So I like to do big exponent minus a small exponent. So I do 5 to the 4/3 minus 1/3. Same denominator of 3. So I'm going to do 4 minus 1, which is 3. So I get 5 to the 3 over 3. 3 over 3 is 1, so I get 5 to the first. Where was my bigger exponent? It was in the denominator. So for this one, I should get 1 over 5 to the first, which is just that. So 1/5. And if you did top minus bottom, you do 1/3 minus 4/3. 1 minus 4 is negative 3. Negative 3 over 3 is negative 1. So then it would be 5 to the negative 1. Bring that down, 1/5. So a number of different ways you could do that one. Number 18, x to the negative 5/7 times x to the 8/7. So let's go ahead and multiply by the same base. We add exponents, so negative 5 over 7 plus 8 over 7. X to the negative 5 plus 8, because the denominators are the same, so negative 5 plus 8 is 3, so we get 3/7. Nothing that I can do there. Number 19. 3x 1/5 being raised to the 4th over x to the 1/20. So this whole entire expression is being raised to the 4th power. So that means I have to do 3 to the 4th and x to the 1/5 times 4, because I'm multiplying 4 times 1 is 4, and then 1/5 times 4. So that's going to be straight right here. 3/4, sorry, not 3/4, but 3 to the 4th, which is 81. So 81 x to the 4/5 over x to the 1 over 20. 81 doesn't have anything to simplify with, but I do need to simplify x to the 4/5 over x to the 1/20. So I would do 4/5 minus 1 over 20, because we're dividing by the same base. Make these denominators the same, so I just have to make them both 20. So it's going to be 16 over 20 times 4. 5 times 4 is 20. 4 times 4 is 16. So I have 16 over 20 minus 1 over 20, which is going to be 15 over 20. I'm getting really close to my camera. 5 goes into 15 3 times. 5 goes into 24 times. So I get 81 x to the 3/4. Big exponent was on the top, and I did big minus small. So in terms of like new skills, nothing really new there. It's just making sure you know the rules of exponents when we're dividing by the same base, multiplying by the same base, that kind of stuff. So it's just really pulling on that type of knowledge. So look at number 20, x to the 2/3 times x to the 1/3 minus x to the 5th. So we're multiplying, so we have to distribute x to the 2/3. So I'm doing x to the 2/3 times x to the 1/3 minus x to the 2/3 times x to the 5th. When I'm multiplying by the same base, I add the exponents. So this is going to be 2 plus 1, which is 3. 3 over 3 is 1. So x to the 2/3 times x to the 1/3 comes out to be x to the 3 over 3, because the same denominator of 3. 2 plus 1 is 3. 3 over 3 is 1. So I get x to the first minus then x to the 2/3 times x to the 5th. That's going to be 2/3 plus 5 over 1. Make the denominator 3. So that's 3. That becomes 15. 15 plus 2 is 17. 17. 17 over 3. So x to the 17 over 3. So x to the first, or just x, minus 17 over 3. Next set of examples here are just really applying all of the different rules and trying to work through some things almost like a puzzle. So in 21, we have the 10th root of x to the 5th. So we want to understand, what is this telling us? What is that index telling us about the fraction portion? So x to the 5th being underneath the 10th root, I can rewrite this as x to the 5 over 10. Just remember thinking back to, let me go back to the first slide here, or like right here. 9 to the 3/2, for example, was the square root of 9 being raised to the 3rd power. Our denominator told us our index, and then the numerator told us our exponent. So if I have the other direction, if I have the radical, I can go backwards back to this form, because this would convert to the 10th root of x to the 5th. Okay, now what can we do? Well, this simplifies. 5 over 10 simplifies down to 1/2. So this is x to the 1/2. What is x to the 1/2? X to the 1/2 is the square root of x. X to the 1/2 is the square root of x. Done. That is now simplified. (22) The 6th root of 25. This looks kind of weird because you're like, well, 6th root of 25, I can't take the 6th root of 25. There's nothing to the 6 that would give me back to 25. So what could I do? Think about this again. This is 25 being raised to the 1 over 6. What is 25? How could I rewrite 25? 25 is also 5 squared being raised to the 1/6. When I have a power to a power, 5 to the 2nd to the 1/6, what operation should I do? Multiplication. So 2 times the 6th is 2/6. What does that simplify down to? 1/3. So this is 5 to the 1/3. 1/3 is the cube root. So after the dust settles, after all of that crazy fancy footwork, I get the cube root of 5. And again, 25 is 5 squared. 5 squared is being raised to the 1/6. 2 times 1/6 is 2/6. 2 over 6 simplifies down to 1/3. So that gives us our cube root. Very fancy. Very tricky at first. Let's see, what could I do with this one? So this is the 4th root of x squared y to the 6th. So what I would do for this one is I would just rewrite this as x to the 2nd, y to the 6th, all being raised to the 1/4. Just take a step somewhere, like just move in the positive direction here somewhere. So I did that. Now, if I identify that I have this whole entire expression of x squared y to the 6th being raised to the 1/4, everything is power to a power. That means this is going to become x to the 2nd over 4, because 2 times 1/4. And this is going to be y to the 6th over 4, because 6 times a 4th, 6/4. Now I can simplify those exponents. 2 over 4 is 1/2. Y is 2 goes into 6 3 times. 2 goes into 4 twice. Nice. They are all underneath the radical then of square root, because both denominators are 2. The denominators have to be the same in order to like simplify down underneath one radical. So since both denominators are 2, this is going to be the square root of x to the 1st, y to the 3rd. See that? X to the 1st, because that numerator is 1, y to the 3rd, because that numerator is 3. And they're both underneath the denominator of 2, so that means the radical then would be a square root. So square root of x, y to the 3rd. Oh, this one looks tricky. 24. Square root of x times the 4th root of x. Let's see. I just, whenever I don't know what to do, I would just start rewriting, move things around. Let's see what happens. So this is x to the 1/2, because this is a square root, times x to the 1/4, because that's a 4th root. Okay. Now what? Well, I have multiplication of the same base. That leads me then to the fact that, well, if I have multiplication of the same base, what do I do with the exponents? I add. Let's go ahead and do that. So I do x to the 1/2 plus 1/4. Same denominator of, or not same denominator, but make the denominators the same of 4. So that's going to be 4. That's going to be 2, because 2 times 2 is 4. 1 times 2 is 2. So this is x to the 2/4 plus 1/4. Same denominator for 2 plus 1 is 3, so 3/4. So x to the 3/4. So I get the 4th root of x to the 3rd. And all that simplifies down. It looks kind of weird. Like, it looks crazy that how do I get from here to here? Like, how do I get down to the 4th root? And if you just start rewriting things and moving things around and reorganizing and just understanding your rules, then it breaks down pretty nicely. 25, the 3rd root, or the cube root, excuse me, of y over the 4th root of y. So do the same thing, just start rewriting. So this is going to be y to the 1/3 over y to the 1/4. What do I do when I'm dividing by the same base? I subtract. So this is going to be y to the 1/3 minus 1/4. Make the denominators 12. So this is going to become times 4 times 3. So 4 over 12 minus 3 over 12. 4 minus 3 is 1. 1 over 12. So this is going to be the 12th root of y. Weird answer there. The 12th root of y. All right, last one. Probably the trickiest one. This is kind of hard to wrap your head around at first. We have the square root of 3 times the cube root of 2. So like I've been saying, rearrange, change some things around. So this is 3 to the 1/2 times 2 to the 1/3. All right. Well, that's kind of weird because I really don't have much help. So I guess our next step would be to try to make these denominators the same. Because if we get the same denominator, then what we can do is we can put it all underneath the same radical. Because right now they're underneath 2 different radicals. One's a square root, one's a cube root. So we really can't do a whole lot with this, and they're not even the same values where I can't use the multiplication of the same base rule where I have been with these, like this is x, y, and y. I don't have that luxury. So let's try to make the denominators the same by making these 6. So I'm going to multiply this by 3, multiply this by 3, multiply this by 2, multiply this by 2. So then I'd get 3 to the 3 over 6 times 2 to the 2 over 6. Now I have an idea here where they're both over 6. So I could put these both underneath a 6th root. This would be 3 to the 3rd times 2 to the 2nd power. See that? Both denominators are 6. So that means they're both underneath that same radical. So the 6th root of 3 to the 3rd times 2 to the 2nd. Now I can just take 3 to the 3rd, multiply by 2 to the 2nd. So 3 to the 3rd is 27 times 4, which is 108. So I'm going to take the 6th root of 108, like that. And I highly doubt that that's going to be a perfect number. Nope. So that means I just get the 6th root of 108. Like that problem out. Really cool. The fact that we use this idea that we're going to make these denominators the same. So then we say, well, these are both the same denominator, 6th root, and then multiplying 3 to the 3rd times 2 to the 2nd is 108. So big section here. I think probably this last couple problems is where you might have had the most trouble. So that's something you might need to practice.